Here we go with 1.1, Part 1 notes. A point is a location in space. It's named with a capital letter, and we're all very familiar with that. A line is a series of infinite points in a row. It's named in two ways. It's named by 2 points on the line, or it's named by a lowercase cursive letter. So for example, if this one had an M here, I could call it line M, or I could call it line XY with the arrow above, or I could call it line YX. The order doesn't matter. A plane is a flat surface extending infinitely in all directions. Okay. So think of a flat sheet of paper extending in all directions. To name it, you choose 3 non-collinear points. Non-collinear means that they are not on the same line. We'll talk about more on the next page. Or you name with the uppercase capital letter. That it would probably be in a corner. So if this one had an L here, we could call it plane L. Or if it had 3 points that were not on a line, we could call this plane A, B, C. A segment is a portion of a line with distinct endpoints. It's a chunk that's been cut out. To name it, you use the endpoints. And the order doesn't matter. So for example, I could call this AB, or I could call it BA. A ray is also a portion of a line, but this time we have a distinct endpoint and it continues infinitely in the other direction. So when we name it, we have to be a little bit more precise. We always start with the endpoint, and then we pick another point on the line in the direction we want to go. So for example, this ray would be ray DE, starts at D and continues in the direction of E. It would be wrong to put ray ED. An angle is our last term that we need to define. This isn't working. An angle, is the last term we need to define, and that is a figure formed by 2 rays sharing a common endpoint. The endpoint is called the vertex, and these rays are called sides. Naming is a little tricky. There are 3 ways to name. You can name with 3 points, the vertex always being in the middle. You can name with the vertex only. But you have to be careful with that. Or you can name with a number. Now what you'll see is that sometimes angles will have a number in them. So for example, I could call this angle 1, and I would know what it is. I could call it angle Q by vertex only, or I could use the 3-point method and call it angle PQR or angle RQP. Either is correct, just notice that I have Q in the middle. Where you have to be careful with vertex only is if you have more than one angle coming out at a vertex. For example, in this scenario, you have angle SQT, you have angle TQP, and you have angle SQP. So if you only called it angle Q, you wouldn't know for sure which one it was. So you want to always be sure to be clear. Collinear means exactly what it sounds like. It's points on the same line. Non-collinear is not on the same line. Coplanar are figures in the same plane. Those figures could be angles, lines, segments, etc. Non-coplanar is not in the same plane. These 4 terms just give us a clearer idea of how to draw our pictures. Postulates and theorems. Postulates are mathematical statements accepted as true. They have not been proven. We have to take them on faith. And there are a few of them. Theorems are statements that have been proven true. Somewhere in mathematical journals, mathematical textbooks, there are proofs, step by step, of all of these. The reason that these 2 things are important, along with definitions, is these are our reasons for proofs. This is how we justify each one of our steps. These 6 postulates kind of make up geometry. They make things behave the way we want them to. A line contains at least 2 points. If I had A and I wanted to talk about the line through A, there are actually infinite number of lines that make this up. So there's no way of knowing for sure what line I'm talking about. The intersection of 2 distinct lines is a point. If I have 2 lines out here, I need to know that they intersect in a point in the middle. The intersection of 2 distinct planes is a line. If you have a plane and then you have another one that cuts through it like such, where they intersect is a line. If you think about the seam, that is a line where 2 planes would intersect. Through any 2 points, there exists exactly 1 line. This is to prevent, here's a line like we know it and want it to behave. If we allowed more than 1, we would get this. And we don't want our lines to behave that way. Through any 3 non-collinear points, there exists exactly 1 plane. So I could have a plane like this, and I could put 3 points on it, but the 4th point will jump off. I can contain any 3 anywhere in space, but the 4th one I can't maybe contain. And for any 2 points in a given plane, the line containing those points is in the same plane. And that's easy to see that if I am connecting and creating that line